Today I will be introducing you to the unit circle. We're going to talk about what a unit circle is, and we're going to check out and see what the x coordinates mean, what the y coordinates mean, and how this relates to SOHCAHTOA. So first, the definition of a unit circle. The unit circle is a tool used in understanding sines and cosines of angles found in right triangles. Its radius is exactly 1 unit, and the center is at the origin of a coordinate plane. So here we have a coordinate plane where you can see a circle is drawn with a radius of 1 unit. So if you look to the left and to the right, up and down, it's all hitting basically 1 unit on the x-axis, positive and negative 1, and 1 unit on the y-axis, positive and negative 1. When we draw a unit circle by itself, we actually do a pretty zoomed in version of this. And so what you're going to see most of the time is just a huge circle, but just keep in mind that that huge circle is still going 1 unit left, right, up, and down. All right, so we're going to connect something we may already know. If we're at the part where we're learning about the unit circle, we should already know about SOHCAHTOA. So first, let's look at the old of what we might recall in geometry. So if we have a right angle triangle, the first thing we usually label is the hypotenuse. That is opposite the right angle. So the right angle is over here. That means that the opposite side to that is the hypotenuse. And then opposite to the angle, we have the opposite. So if the angle is right here, then the opposite is on this side. And then the third side that's left over is alongside the angle is going to be the adjacent. So that's the adjacent right there. We can also recall that we have some trig functions that go along with this, hence SOHCAHTOA. We have sine, cosine, and tangent. Now, what does the SOH stand for? Well, it's opposite over hypotenuse. The CAH stands for cosine theta equals adjacent over hypotenuse. And the TOA is for tan theta equals opposite over adjacent. From this, we get the reciprocal, which is the second 3. Cosecant, which is the reciprocal of sine, so that's H over O. Secant, which is the reciprocal of cosine, so that's H over A. And tan, cotangent, which is the reciprocal of tan, which is O over A. Now let's convert this to the new SOHCAHTOA, which would be in terms of X, Y, and R. So here we see we have the same triangle, only it's labeled a little bit differently. So let's say the angle is in standard position. If you remember what standard position is, it's when it starts on the positive x-axis, and as you rotate around counterclockwise, you have a positive angle. The opposite side is actually going to coincide with whatever y value you have. So this point, the y value will be the opposite side, and the x value represents how far along the x-axis you are. So this x value represents how far along you are on the x-axis. So our new opposite is y, and our new adjacent is x. We're going to call r the hypotenuse. The r is going to mean radius. It's going to mean the radius of the circle. So sine used to be O over H is now y over r. It's still opposite over hypotenuse, but we are calling y the opposite, and we are calling r the hypotenuse. So what does that make cosine? Well, if adjacent is x, that makes it x over r. And And what does that make tan? Tan is opposite over adjacent, so that's going to become y over x. All right, and then the reciprocal functions, you just get the reciprocal. So you have r over y, r over x, and x over y for the reciprocal functions. Now, what does this have to do with the unit circle? Well, what we're going to do now is we're going to take this triangle and we're actually going to fit it inside of a circle. So as you can see, we have fit this inside the circle, and as I rotate this, I'm going to get a triangle every time. So on this point of the unit circle, sine of the angle would be y over r, cosine would be x over r, tan would be y over x, so on and so forth. So what is r on the unit circle? Well, we mentioned earlier that in order for it to be a unit circle, the radius has to be exactly 1 unit. So r is always going to be equal to 1, because if it wasn't 1, it wouldn't be a unit circle anymore. The x coordinates are the exact values of, now check this out, if r is 1, and we look at cosine, cosine is x over r. So if cosine is x over r and r is 1, that means that cosine is x. So the x coordinates are the exact values of cosine for each angle on the unit circle. Remember, we're going to draw multiple right angle triangles on this unit circle. So take a guess as to what the y coordinates are. You may have guessed it. Sine is y over r. And if r is 1, that means sine is going to be equal to y over 1, which means sine is y. So if sine is y, that means that the y coordinates are the exact values of sine theta for each angle on the unit circle. All right, so that's what the unit circle is. We're going to take a look at in the next video, we're going to take a look at some common angles in the unit circle.